Hello everyone, today I have an interesting board. This one is TUF B650-PLUS WiFi. So this board looks almost new. It has stickers, it has nice high-speed USB ports. It's quite modern one. However, we already see it has problems. It goes as a board which do not post and there is no other comments. But I see actually that this board was already repaired or tried to repair by someone or uses a donor board for the MOSFETs. There's no MOSFETs. We'll take a closer look with the microscope. And we'll need to look at what we have near the SIO area. The SIO is located at the center of the board, this one. And so I already take a look at this socket and the socket is clean. There's no any damage or anything that could prevent us from booting. However, I don't know what secrets are under those heatsinks. That could be also blown MOSFETs, removed MOSFETs, as well as PCH that could be actually absent. So let's take a close look at this. And so this area, okay, where all the MOSFETs and the nearby circuitry is removed, it's not knocked off, so it removed very careful since I see just a small burned connector at the bottom, but that's really accurate. And there's no damage on the memory slots. So this is the problem number one. Let's see what we have here. Do we have any more knocked off, removed, desoldered components? Or this is the only problem which we can visually detect. The SIO. I guess it looks normal here. Let me just double check this. Yeah, because those components shouldn't be here. So you see that there's a bunch of the components which are just not soldered. This is normal. Okay. So the SIO area looks normal to me. Let's see what we have right here. This is usually the part which is often damaged here in knocked off components because the graphic card is on this slot, and when you try to mount it off, so you can knock it off easily here, or make a scratch and have a trace damage. So here it looks normal. Let me go up, and oh, here we go. That's a knocked off component over here. This one, and I guess the sticker with the scratches for some reason. Why, I don't know. Do we have any damage under this? Or this is just a sticker? No, no damage. Okay. Okay, let's go next. No damage here. This is an audio chip. It's covered, so I guess it's okay. I don't have anything on the back. Locked off. Just put the microscope up a little bit. And this looks normal to me. The other area with the components. There's something here. This is usually also the area which could be often damaged because of that screw. But this screw looks virgin. So, okay, I go next. And the CPU area. Where's my focus? Okay, here. What else we have? We have the MOSFET drivers usually here, but there's just the capacitors. But we have also a small resistors. So we have to check if they're all present over here. Those are the VRM part. And this is RT3672 Not sure what it is, but also the screw is quite close to the chip and circuitry. Okay, it looks fine. And I guess we don't have anything more on this side, so let's try to measure the resistance. I guess there's no way that it will power on and pass without those MOSFETs. So those MOSFETs are probably something related to the DDR memory. I'm not sure, like if to see using the board view. We can check the resistances just to see if anything shorted out. Let's find a nice ground. So 3 volts normal, 5 volts as well, 12 volts, then mega ohms, okay, 5 VSB, almost 50 kilo ohms, okay, minus 12 mega ohms, the CPU power, CPU 12 volts, kilo ohms, it's not shorted, and let's find any MOSFET or even a coil and measure if it's not shorted to ground. Mega ohms here. So then let's see, do we have our problem VDDQ, and we have kilo ohms, so there's no short. This is the CPU power, kilo ohms here, and the memory 2.5 volts, 5 kilo ohms here. Okay, I have this MOSFETs in stock, so I will be able to replace it. But first, what I'd like to check if we have a shorted PCH, because it's quite weird why someone wants to remove 4 MOSFETs, like regular simple MOSFETs, from this motherboard. And so maybe the situation is that the PCH or SIO is dead over here, and so this board has been moved to donor boards or whatever. So this MOSFET is producing the power, supplying power for the PCH. Let's measure the resistance on it. So placing one probe to ground, another probe, this MOSFET. So those 3 pins are basically the supply voltage. And we have 109 ohms. This is normal. So PCH is most likely alive. What I would like to check before I do this procedure, because this is quite not a simple repair, because there is a plastic parts, the DRAM slot and the ATX24 power socket over here, header, and so that's the MOSFETs. They are power MOSFETs, and so they have a very large copper parts under it. So I probably will need to apply quite high heat, 450 Celsius hot air right here, just to solder them quickly. And so I need not to melt the connectors here, because otherwise the board will be damaged. So let's move those heat sinks and try to look at the MOSFETs of the VRM. Okay, I'll just remove this one. Looks nice. Usually there is a damage on those pads, but they're clean, so it means the MOSFETs are intact. Let's try to remove this. Okay, also looks clean and nice. This is a good sign. Someone just removed the MOSFETs from the VDDQ. The board is working. It's just quite strange for me. So I don't see anything bad, and VRM looks normal. Let's try to put the MOSFETs in their places. Put this resistor or capacitor, whatever it is, knocked off here, and try to power it on after that. I guess the story was that this knocked off resistor prevented from booting this motherboard, and they just throw it to the donor bin, and so they used it even for the MOSFETs to repair something else. This is very strange. Okay, let's do it. All pads have been prepared and ready for chips to be soldered. I will need to tin the MOSFETs before soldering them to ensure a good connection with the pads. And unlike this capacitor over here, which we need to isolate as well, and that could be a problem.
Spacecraft is ready for docking. You gotta be careful.
Here should be a condensed capacitor. There should be a capacitor and a resistor. So, and here should be a capacitor. We are going to solder it later up to the MOSFETs. So I'm not preheating the board, and I am going to work with 30 degrees Celsius, and I got a 60% of flow. Okay, I'll put around the cups, close as much as I can. Dropped the wrong way. There's a resistor here, but we need a capacitor right here. This is a filtering capacitor for this MOSFET. Okay, and the 0 ohm resistor within 6 LQ package. And do we have another capacitor? We do. We have another capacitor, but it is going to be 4,700 picofarads, which is, as I understood, 4.7 nanofarads. This cap goes right there. Another filtering capacitor. Okay, so really doesn't want to. Okay, yeah. Okay. So 3 zeros on that means it's 0 ohm. Not 1 0, not 2, but 3 zeros. Don't ask why. Okay, and so it looks like this is all we should solder here as well. Okay. Let's now grab the same 430 degrees, but around 25–30% of the flow, because the capacitor and the resistors, they can just fly away. who did decided to remove those MOSFETs, 2 caps and a resistor? Well, I don't know what the purpose of damaging such a nice board. Now let's try to clean it. This is also the challenging part, since my toothbrush does not fit such a small hole here at all, I would say. Well, we'll find a way. Let's grab a interesting pipe here. The delicate task wipers, especially for scientific job, says the science. Now this is basically a science, right?
Five minutes later.
I can't say it's better than factory, but it's better than the damaged board. And we'll see if it's working. And for whatever reason, it was desoldered. Those MOSFETs were desoldered to the board. I guess that we also have this knocked off resistor over here, which could be potentially the reason why those MOSFETs are actually has been removed. Okay, I need to remove this sticker. Otherwise, when I apply hot air to this area, the sticker will melt. And believe me, the smoke from the melting sticker is not the best. Okay. Yeah, this is a capacitor. It's 5,600 picofarads capacitor in 603 package. MOSFETs are soldered, capacitor is found on the donor board and soldered as well. Let's power it on. Okay, we have 72 milliamps and no reaction to the power button. Okay, let's put the CPU in and find why there's no reaction. Why there is no reaction? It's because someone has soldered something else from here, or we have AM5. I have Ryzen 5 760, and we should place it. Here are the keys. Here are the keys. Okay, let's power it on. Okay, 106 milliamps, much more, it's better. Pressing the power button, we have a reaction. This is a really good sign. And we have a DRAM LED, CPU, and VGA. Wow, fantastic. Really? Okay, this could be a success with this board. Let's plug in the HDMI capture here. Okay, I have DisplayPort and HDMI over here. And I will show you the post screen here. Okay, starting up, pressing the power button. Here we go, here we go. Right, hitting, just in case it will hit really. Okay, boot. Do we have a picture? will it pause or no? So there's something with my capture card, I guess. Okay, so let's do it again. Power on, 105 milliamps. Pressing the power button, and see, we should have a picture over here. And when we do, okay, so this board is fixed.
Flawless victory.
So we have a working board right now. Someone has removed 4 MOSFETs from the VDDQ memory power line, and the board was working before that, which is quite strange. I think it might be because a capacitor was knocked off earlier, and that would have prevented the board from starting. Technically, that capacitor isn't a filtering one, but more of a delay capacitor, so maybe it interrupted the power on sequence by not supplying the signal at the right time. Overall, this is a fantastic board. It's packed with high-speed USB ports, multiple controllers, so it's great for gaming, streaming, or video recording. It's just a pity someone did this to it. But who knows, maybe they were trying to save another board that was worth more than this one. Anyway, it is what it is. There's no real damage to the socket or connectors, maybe just a small mark down here at the bottom, but that was already there. So as of now, the board is working perfectly. It's going for testing next, then final assembly, and that's it. We've done it. If you enjoyed this repair, don't forget to hit like, subscribe, and share it with someone who might find it useful. See you in the next repair. See ya!